Hi there สวัสดีครับ You are watching Dr. Green channel. Today we are going to discuss about how to choose the solutions for unstable power problem. Because we might have experience and also our customers who live in the rural area and also in the city face the problem of the unstable power input from the grid. And we provide the solutions to the customer according to the problem that they are facing. So today we will discuss how could we identify whether your home or your place have the problem about unstable input power from the grid. And once we can identify the problem, we will discuss about the solutions. So how can we do the system design and also how to choose the product or to choose the solutions according to the use case. Alright, so we first discuss about the symptom of the power unstable or the input power unstable which coming from the grid to our home, to our office, or coming to our locations, our places. So the symptom of the grid power unstable is sometimes the lights dim by itself, and you can notice that even the fluorescence or just the bulb lights is dim, and then some in the short time it will come back again, and this sometimes happen when the peak hour. That mean when the people using the electrical power, when they come back from the office, at home they will start to turn on the electrical appliances. So if your area can provide the electrical power in the adequate capacity, then you don't have this kind of problem. But the people who live away or live in the rural area or living in the last mile of the power cable that laying to your house, and unfortunately that was the last mile for the power cable, then in this case even you live in a city or you live in the village or the villa in the city, you might face this grid power unstable problem. So again, if you have noticed the symptom that the light dim by itself, or sometimes the fan turns slower by itself, and also even the air conditioners, the speed of the wind, because the fan inside the air conditioners turn slower, so the wind come out from the air is not strong as usual. Or sometimes the temperature is not reducing according to the normal working function of the aircon. So you can assume that you have the problem about the grid power unstable at your home. So we can see and understand the characteristic of the power unstable. So the first one is the voltage drop. So in this case, as I give the example before, in the peak hour when the people use the electricity when they come back from home, for example, from 5 p.m. to 10 p.m. These consider peak hours. So if you live in the rural area or live in the last mile of the power cable that has been installed, so you will face the power drop. Once the power drop, then the light is dim by itself, and also the cooling fan or the air conditioners, the speed of the wind will not strong as usual. So this is the most case of the power unstable that we will face. All right. And in the next scenario is over voltage. So normally the normal working range of the incoming input voltage from the grid will be about, for example, like 220, 234, 238, something like that. But if the voltage is over than that, that will also cause the appliances working abnormal, or sometimes can harm your electrical appliances. So it can cause the faulty, or sometimes you need to send these appliances to the service center. Okay. And the last case is the surge and the spike. So in this case, you will find, if you live nearby the industrial park or the industrial area. So once the factory turn on the motor or the pump, sometimes it will cause the spike and surge because of that particular load is power off and power on. So if you face this kind of scenarios, this kind of problem that we have discussed, so you have to looking for the solution to make the power stable. That's why we will introduce the stabilizer for these discussions. Okay. So if you have, again, if your home have the problem about the power unstable, so it will cause the problem to every appliances in your home. Sometimes it's faulty, sometimes it stop working, and sometimes you have to buy the new one, which is the worst case. So how to prevent this problem and how to solve the problem. Okay, before we are going to discuss about the solution, so we have to touch about some basic when we talk about the power and also the VA. So I think most of you have seen the VA, you have seen the W. So these are the unit, okay, of the apparent power, which is the VA, and the active power, which is the W, and also the reactive power, which is represented in VAR. So these three parameters will be considered, or time to times when you design the system, you have to taking into account to improve the efficiency of the system. That means it will contribute to improve or can impair the power factor of the system. So you can play around with the inductor and the capacitor to improve the power factor. So in detail we will discuss later, but in this discussion we will talk about the W or wattage and also VA and also the angle, the theta over here. So the first one we will talk about the power factor. Power factor is equal to the active power divided by the apparent power. Okay? So this is the cos theta. Okay? Because the cos is this side, okay, of the triangle divided by the S, which is the apparent power for this case. So from this page, we will taking the power factor, which is equal to cos theta, to discuss in the next page. Okay? So you will understand when we talk about the VA and W and how to convert between these two. Because if we talk from this formula, P is equal to S times cos theta, or the wattage or the active power is equal to apparent power multiplied by cos theta. Okay? Or the apparent power multiplied by power factor. Alright? So the wattage is equal to VA times power factor. So this is the simple way that we will use in the next slide. Alright? So from the relationship of the VA and the watt from the previous slide, we can discuss continuously when we do the system dimensioning. So the first factor that we need to aware or taking as the input is, in Thailand the voltage, the system voltage is 220 volt, 50 hertz. Alright? And for example, when we do the calculations of the maximum power, so we will use the 220 multiplied by the maximum rated current, or equal to voltage multiplied by rated current. P equal to V times I rated for these equations. Alright? And normally, after the design, we will also keep the safety margin for 20 to 25%. Okay? For the surge current of the particular load. For example, the pump, the water pump, or the traditional air conditioners. And we can discuss about the design from the number third that we are going to discuss here. So in this case, if we would like to calculate the VA, because for the stabilizer, the capacity of the stabilizer is stated by VA, or the unit of the capacity of stabilizer is VA. Alright, so we need to convert or calculate the wattage to VA. Alright, so if we remember the formula from the previous page, VA is equal to wattage divided by power factor. Alright, so VA, alright, VA, which is represented by S from this equation. S is equal to watt, all right, divided by power factor. All right, so that's why this equation is written like this. So we will show you the calculation of the VA, all right, from knowing the watt value. So in this case, we will put the 1000 watt, okay, divided by power factor. In this case, is 0.8. So we get the apparent power value, which is equal to 1250 VA or 1.25 kVA. Okay, if we divided this VA number by 1000, so we get kVA. So for this example, 1000 watt. Okay, if we are using the power factor by 0.8, so we will get 1.25 kVA. All right, and most of the case, if you are calculate the apparent power for your home, so normally you can use the power factor as the 0.8. But if you design for the industrial system, so we need to collect the power factor for each particular load, which will be different from the residential use case that I give example here. Okay, but most of the case, if you are calculated the VA or the apparent power from the knowing wattage value of the appliances, you can convert by using this formula, which is very easy. And if you are going to convert the BTU value or the tons to the kilowatt, so you can using this formula. All right, so the power consumption is equal to cooling capacity in kilowatt divided by the energy efficiency ratio or the EER. So in this case, I give the example like add condition 1.5 tons or equal to about 18,000 BTU. All right, so in this case, we can calculate very easy. So we multiply 1.5 tons with 3.517 to convert 1.5 tons to kilowatt. Then we divided by the EER value, which is this case is 2.7. So you can find this number from the label on your air conditioners. So in this case, the power consumption is equal to 1.954 kilowatt. So now you can input the wattage into the table to make the system dimensioning or the stabilizer dimensioning for your home. All right. So in this case, I will give the example like we use the submersible pump for 2 HP, and we use the refrigerator 9.5 cubic, and the television 42 inch, and the air conditioners 9000 BTU. So we can calculate the wattage and then put in these tables. So now you can convert, okay, from the wattage to the VA by using the formula on this second slide. Okay, and now from the minimum input voltage, it's very important to choose the stabilizer. So in this case, you want to choose the stabilizer that take care of all appliances in this table. So you have to choose the mainline stabilizer, which can work at all times. So that means you can turn on this stabilizer 24 hours all the times. All right. And by this table, the capacity of the stabilizer, we can use 5 kVA. And the minimum input voltage in this case is 110 volt. So we will use the wide range stabilizer, which this model can support from 70 volt to 290 volt. And the feature of this stabilizer also support the high cut, low cut, which is very good to save your appliances. And also the stabilizer, this stabilizer have the inbuilt bypass switch. So that means this is very good when you want to do the service for this stabilizer. So you can turn on the bypass switch and turn off the stabilizer to just bypass the input grid power to your appliances in this case. So you don't need to buy any extra box or any additional box for the bypass MCB, all right, which is inbuilt for this stabilizer. And also this stabilizer is working as the zero touch, so it is not depend on the type of the load. You just turn on this stabilizer and it will work automatically for you because this stabilizer is using the microprocessor. And for this table, the customer is using the submersible pump. So we can choose this model because this has very fast response, which is working very good for the submersible pump. That's why we choose this model, the Dr. Green Lift Guard LM510XS for this case. Alright, so this is the example. And not only the stabilizer, you have to choose the suitable power cable for your system. So you have known the wattage, you have known the VA, so now you can calculate the current. So once you know the value of the current of your systems, you can choose the right size of the power cables. All right. So we have to choose the right type of the power cable, and we also need to choose the proper sizing for the power cable as well. All right. So you can have many options to choose the stabilizer from Dr. Green, which we have from one phase, and also we have the three phase stabilizer. So in both cases, when customer require the single phase or the customer require the three phase, we also have this stabilizer which can provide the stability of the electrical power in your home or in your office or in your factory. So on this side, you will see the big capacity, which is 10 kVA, 20 kVA, and 30 kVA. So we have shown and doing the video introduction for 20 kVA and also the 30 kVA, which you can find in the other video on Dr. Green channel. And we also have the 5 kVA, which is very suitable for the residential system. So if you use at your home, or you using at your office, or maybe home office, you can choose this model, which is 5 kVA, and the cost very good for the investment. And we also have the specific stabilizer, which is work for the air conditioners, which help you to choose easier and also to invest lesser. So with the air conditioner stabilizer, you don't need to use very huge capacity of the stabilizer to manage the whole appliances in your home. So in this case, you can choose the smaller size of the stabilizer, which can help to lower the investment, and also to choose the proper size of the stabilizer to match with your air conditioners. For example, on the right hand side is the stabilizer for the 2 tons or 24,000 BTU. So you can choose this model. And if you have the air conditioner with 1 ton or 1.5 tons, you can choose this model. Alright, which shown on the left hand side. And these two models has very good. It is coming with the power cables with 3 times 2.5 square millimeters, which you help you to convenience to install this stabilizer. Don't need to go out and buy the accessories again. And last but not least, for this air conditioner stabilizer, it has certified with the ISO standard and also some other safety standard. So we also talk about the hybrid inverter. Of course, these two inverters can work with the solar. And without the solar, if you connect this with the battery and connect with the grid power, it also can work as the power backup system for your home, or also for your office or your home office. So it can support to provide the power when the power outage. So if in the case of power outage, you can use this to still continue to supply the power to the loads. Or maybe you will have time to proper shut down your systems or shut down your computers, or to save the files that you are working and then do the proper shutdown. So this will help to extend or to prevent the faulty to your appliances, especially the computers, which is very sensitive. So we have shown the two solutions, which are the stabilizers, which can help to stabilize the voltage to prevent the possible voltage drop and also the over voltage from the incoming grid power. And also, if in the case of the grid power is outage, you still can have these to back up the power for your appliances. Of course, the left hand side has the bigger capacity, and the left hand side and the right hand side here has the smaller capacity, which is 1500 VA, and for this one is 2 kVA or 2000 VA, right? And this one on the left hand side can run the air conditioners 9000 BTU, for example. So let's coming to the summary. So for the point that we have discussed previously, so the stabilizer that we have discussed or proposed to you in these presentations can help you to lower the TCO or the total cost of the ownership, because you don't need the single large stabilizer to accommodate the air conditioners, to accommodate your all appliances in your home. So you can do distributed. Alright? So once you do distributed, you will invest lower or pay less. And this will contribute into the installation accessories. For example, if you deploy the large stabilizer, of course you need to buy the big power cable. And the big power cable, the bigger size of the power cable is very costly and also require the professional engineers and more complicated tools to work on those big size power cables. Alright? And also the distributed architecture is the new architecture which can help you to work easier with the smaller size of the stabilizer and also smaller size of the power cable. And also we have introduced the air conditioners stabilizer, which you can deploy along with the air conditioners. So these stabilizer will take care of your air conditioners. So don't need to deploy the big size stabilizer to accommodate all air conditioners in your home. So this also help you to save and lower the TCO. And in some case that you have the very long power cables, or the point that you install the water pump is very far away from the point where the power is reaching. So you need to run the power cable in very long distance, maybe in the kilometers. So in this case, you can use the donor architecture solutions, which we have introduced in the previous video in the YouTube. So you can find that as well. On the second point of the key takeaways is, you don't need to, as I mentioned, you don't need to deploy very huge stabilizers. So once you can avoid the huge size of stabilizer, it will help significantly on the power cables. For instance, the power cable, the size, the bigger size of the power cable, the more expensive that you have to pay. Alright? So if you are looking for the solutions to help you to save the cost or to save the investment of your projects in your home, so you can looking on the new architecture that we have introduced, or just contact us to get more information. And of course, if your system is not big or require not big size of the power cable and accessories, so you can install easier, so you will consume less man day, you will consume less people, so the total cost of ownership will be less, will be lower. Alright, so this will bring the lower capital expenditure and also fast deployments if you are using our solutions. And also this will help to contribute to lower the OPEX, because these stabilizers, all the models that we have introduced to you before, every model, they don't have cooling fan. They use the natural cooling. Alright? So without the fan, there is no any additional power consumption from the fan. So you will have lower electricity bill. Okay? Help you to save the cost of the electricity bill. And also fast response. Because the fast response, it will help you to don't need to send anyone to do the switch when you want to run some particular load. For example, if you want to run the pump, the water pump, in some model in the market, you need to do the switch setting if you want to run that kind of the loads. But for our stabilizer, we don't need to do anything. It will manage by the microprocessor. So it is the real zero touch stabilizer. So it don't need any engineer or the technician to take care or to do the manual switch when you want to run the particular loads. So the overall that we have discussed so far help you to lower the cost, and also don't need the manpower, don't need to allocate the person to sit in that site or at your home, or to go to the equipment room to do some setting when you want to run the particular loads. Alright, our stabilizer is very smart because you don't need to do anything. It will manage for you because inside we have the microprocessor. And with the no cooling fan, as we use the design from the telecom grade, because the telecom equipment is installed on the top of the tower, which the height sometimes is above 30 meters from the ground, or maybe about 100 meters from the ground. So we cannot risk with the fan inside. So from this design, we remove the weakness of the system, which is cooling fan. Alright, so it will help our stabilizer to work longer, to have longer mean time between failure. So you can use longer. Our customers have used our stabilizer for about 6 years, and this is coming to complete the 7 year in this 2019. Our customer very happy because inside don't need the fan. So even it located somewhere not in his home, the stabilizer can run very well. So you can see the advantage of the no cooling fan for the stabilizer. So thanks for the fanless design again. Right. So these are the topic that we have discussed, and for now, I hope you have the solutions for the symptom or the problem that we have discussed earlier. So if your home have problem about the light dim by itself, or the speed of the fan is turned slower, or the aircon, the wind that coming out is not strong as usual, so we can assume that your home have the problem about the low voltage or the voltage drop. So how to solve the voltage drop issue in the peak hour or in the time time range that people use the electrical appliances when they come back to the home. So to solve the voltage drop problem, you can use the stabilizers. Alright? And if you have the problem about the power outage, you can use the hybrid inverter that we have discussed earlier. And when you choose the stabilizer, don't forget to think about these factors or these points that we have discussed earlier. And if you have the problem or you have the questions, please feel free to reach us from the contact information here. So if you like this video, give us the thumbs up, share with your friends in the social medias, and see you again next time in the next video. Thank you very much for watching and see you again in the next video. ขอบคุณครับ สวัสดีครับ